Hello, welcome to Enlightning. I'm so glad you're here, and I'm so glad you're here, Volkan. Will you please tell us about yourself? You're here to teach us about SPIFFE and SPIRE today.
Yeah, as
Yeah?
best as I can.
Inspiring confidence right off the bat.
It's like knowing something is one thing and teaching it is something else. And I find myself a good enough teacher. Like I find, nice analogies and change a complex topic to the level of, like famous style, the level of, whoever wants to know it. But it's also a live event and SPIFFE and SPIRE is relatively involved. So we'll wing it. We'll see how it goes. But to me, like I'm a developer, streamer, speaker, and creator in a sense. I am also a hacker. I like, tinkering with stuff, regardless of, whether I do it at work and outside the work. And like, I'm not afraid of, breaking things. And I have been in the industry for like 20 plus years. I have seen a lot to the point that I want to open a burger shop. And I already have a name for it, like debugger, like debugger, but I don't know. It's cheesy, but
Wait, what's the name for your burger shop?
D-burger, like debugger, but
But debugger.
yeah. And you can order burgers with a GraphQL API if you want to. Let's see. Nowadays, currently, I am a senior principal engineer. Like Broadcom calls it master, but I don't like the word master, so I call myself a senior principal engineer at Broadcom. I'm doing radio access network security along with other things like trying to make the partner experience and the developer experience better and things like that, among with many other things that I juggle. And like I said, I see myself as a problem solver. The problem doesn't matter, it can be anything. The context, origin, the nature of the problem is orthogonal to the fact that you are to solve it one way or another. It begets creativity in that regard. And
I love that attitude.
let's see about the SPIFFE Zero Trust. I have been involved with the community. I don't know, since early 2000s. When I don't know, out of the blue, I figured out there was something called SPIFFE, and then I jumped into it, and it's a really welcoming community. And nowadays, I am one of the 5 chairs of SSC's SPIFFE steering committee, and SPIFFE steering committee is is a like a board that oversees the final decision maker of everything SPIFFE related, including new and upcoming projects and standards and things like that. So it sounds fun, but the job is pretty boring. But somebody has to do it.
It sounds important anyway.
It's
I'll give you
important,
that. I don't know if it sounds fun.
It needs to be there. It cannot be, a single person, because in that case it will be a benevolent dictator, and that dictator can go anywhere. But a quorum helps, things to keep in check. But yeah, it's a important thing, and that's overall more or less me, I guess.
I love it. I love it. At least how you relate to SPIFFE. We have lots of great comments already from the chat. So many friends here. Epic Tralala's here. Hello. Abhishek's here. Hi, Abhishek.
Hi, Abhishek. Yeah.
Findle's here. Findle's like afraid of breaking things. Findle tries to live with the creed. It compiles, then ship it.
Yeah, that's true. Like I am in like a Broadcom is like a 30,000 employee company, but I have been a hacker and a startupist all the time. Like I have been into like 4, maybe 5 different startups, founding a bunch of them myself, and I have seen ups and downs. I have exited with millions of dollars, and I also bankrupted a company. So it's the ship it attitude is it's like done is better than perfect. Perfection is one of the boring things that can happen to you.
Yeah, 100%. I've definitely fallen into that trap when I was younger. I like Findle's comment. It does a thing. Maybe not the right thing, but it does a thing.
Yeah, it does. It's like also like this is not a printed circuit board. We are, as at least us in the IT software, cloud native, whatever industry, we are dealing with software. You can amend it, you can meld it, you can mold it, and also the problem that you solve at like 10,000 person scale is a way different problem that you solve at a million person scale, and you'll have to rewrite everything from scratch anyway, or find someone who does it. So like, why the hustle in that case?
Yeah, love it. We also have Abhishek cheering you on as you were listing all of your accomplishments. Like, go Abhishek.
Abhishek, like, just to, give a pointer to him, he is a core contributor to another SPIFFE-related project, and we work closely together with a bunch of other core contributors as well. Yeah.
Oh, nice. That's great. You could have just pretended a random stranger was cheering for you, and I would have believed it. That's the world I live in.
Random stranger cheering for me to give my, I don't know, to provide myself more recognition, whatever you call it.
Okay, so what I'm going to do now is before the show, Volkan gave me a lot of links to put in the chat. So I'm going to drop all those in chat, and then I'm going to make my way behind the light board and get this thing started. One thing that's pretty exciting about today, / scary, is it's the same feeling. Is that the SPIFFE is pretty notoriously complex, as you said, and I know nothing about it. I'm really flying blind today, so we're really gonna go for it. It's gonna be great.
Okay, like it's fine. Like, but you have done talks related to like service meshes and I don't know, key cloak identity managers and things like that. So I can relate it to the concept of managing an identity plane, I guess. But I can start with I don't know where the project is. Like right now, it's a CNCF graduate project. It's hosted by CNCF and.
I didn't know it was graduated. That's cool.
Yeah, it graduated last year, I think. It is focused on cloud-native security and in 2 aspects. One is securely dispatching identities to workloads at scale, and the other is to like make identities identifiable, like giving you a passport, maybe. Like, how do you identify yourself as a workload? It's that part SPIFFE helps.
Okay.
And how that is done is I can also like I don't know. Do you want to dive into something, or we can take it at surface level?
Not so. You're jumping the gun just a little bit, but I appreciate your enthusiasm, and I think, following most of what you're saying. But I have more questions, but I'm going to wait till I'm behind the board. And meanwhile, you can talk about all the links I just put in the chat.
Oh yeah, piano. Yeah, those are It's fun. I'll circle back. I have two kids. One of them is 9 years old. The other is 11. And 2 years ago, the 11 one says, "Daddy, I want to play piano. I want to play. I love piano. I love the music." And we said,
Nice.
"Okay, we'll get an electronic piano if you so much, and we'll enroll into courses, and you can learn music notation and whatnot." And
Uh-huh.
as any kid, her enthusiasm for piano lasted for a couple of weeks and then faded away. So,
Wait, I have to
uh,
actually work? What's this?
yeah, like I cannot just sit on it and like notes come out of it. So, so like she's now into violin. She really badly wants to play violin, and we have been postponing it
Okay.
for the last 2 years because like I want to make sure that she really really wants it.
Mm,
And we finally
yeah.
got her a violin and like a violin tutor. I think she's liking it. I didn't check on her so far, but she's also, I don't know, 11 is a pre-teen age, so anything can. She's like a compressed teenager. So, like our relationship is like a roller coaster with her, but it's fun. I
Oh,
like her.
yeah. Oh,
uh,
good thing. That's a good thing.
but yeah, back to the piano. Like she left the piano, and we have a piano in the house that, like I don't know, it's over, just sitting there. I sat in front of it, and it was one of the days that I had too much espresso, so to speak. So I just sat on it, and I'm just like playing, like trying to create random noise and random notes, and things come out pretty harmoniously. I realize that I am able
Ah,
to like create sounds, and that sounds sound decent enough.
nice.
So I then started, like I downloaded the piano teaching app, and like started
Mm-hmm.
following. I had some music notation experience, but not like a piano grade. Like I knew treble clef and notes and things like that. But then I figured
Uh-huh.
out by my second month I was playing Moonlight Sonata by Beethoven. So I
How's that
and
go?
I
Sing me a little.
uh, and I'm. It's too early to remember the notes, but it's really
Okay.
a common theme. You probably have heard it. Even you don't know even if you don't know it. But see, let's see. Um, then I googled because like I know my learning pace, but I don't know how and
Uh-huh.
every like am I fast, am I slow? And the research that I made showed that typically to get to that level it takes a couple of years, maybe 4, maybe 5, and
Ah,
I did it like in a couple of months. So I said like I have a knack for it, so like I should go
nice.
for it, I guess. So right now I'm practicing Bohemian Rhapsody by Queen.
Ah, cool. Do you
It is
headbang
hard.
while you play it?
A little bit because like I'm right focusing on my hand, so I am not quite able to get into the zone yet. But once I master it, like I'm on 1/4 of the entire piece. Like the entire piece is like 120 measures, and I am around like 30th measure or something.
Okay.
And
Nice.
you know the sound, you know the music, I guess. So it gets
Uh-huh.
faster and harder and more complicated as it progresses. So
Yeah. Yeah.
uh, I have a goal. Like my goal is to like finish it by the end of this year, like I don't know, New Year resolution maybe.
Mm-hmm.
And I have a second goal. I don't know. I might not be able to finish it by the end of the year, but once I feel like I finish it and I am able to play it at a not bad enough way, I want to upgrade my piano and I get something
Oh,
cooler,
nice.
better. Yeah, yeah.
Yeah,
But
that's a good reward. Yeah.
music
I
is fun. Like I find it
music
like a
is fun.
meditation, I guess. Like when I sit on, and the weird thing is, had I realized this at the age of 7 rather than 40 plus, I would have been in a different sector doing something different, I guess. Yeah,
But it seems to me like your life has turned out pretty great.
yeah.
But
I don't know.
yeah,
Age is just a number. You can go anywhere, anytime, I guess.
I agree completely. All right, so let's learn about Spiffy and Spire. Let's start by saying before Spiffy existed, what
Hmm.
was the world like like what problem existed in the world that caused someone to be like, hey, we need to make this technology called SPIFFE?
Yeah. So before SPIFFE, like there was a way to for workloads to communicate. So there are two ways. Like for one of them is like TLS. You can have two workloads have different certificates, and they can establish a secure bidirectional communication, which is like MTLS, Mutual Transport Layer Security. And SPIFFE essentially dispatches those certificates in a sense at a really high level, but
Okay.
establishing a hybrid cross-cluster, cross-cloud MTLS was so difficult that people resorted to other methods like keeping
Uh,
service keys. And like service key is like a secret token that your service
Wait,
keeps.
you're
Uh-huh.
you're so far ahead of me.
Okay,
Did you say
okay.
workloads communicate in one of two ways, or there are lots of different ways?
There are you can invent a bunch of different ways. But the main ways that they can communicate is either they can use two different cryptographically signed certificates, and then
Mm-hmm.
they can establish MTLS, Mutual Transport Layer
Mm-hmm.
Security, or uh, they can use what's called service keys or service tokens. And a service key is like, I don't know, you and I are talking and we have a common agreed upon, passphrase, like, uh, I don't know, pizza, jelly bean, turtles all over. And when you say it, I am open to, your communication. If you don't say it, I just, no, I don't know you. You don't know the passphrase.
Pizza, jelly bean, turtles all over.
Yeah.
Oh, it's
Uh,
really
uh,
Whitney. Great.
that's like when one service is talking to another, if the service provides and that secret is definitely not pizza, it's like a long string of garbage essentially.
Uh-huh.
The other service, if it knows that is secret, then they can communicate. That's one way to establish that. But in
I
that
have
case, sorry.
I have a
Okay, go
couple of
ahead.
questions. For one, is my video feed jumping all around real weird?
It's
Or is
flicking
that just
into
for me?
magenta and
Okay.
jumping.
Okay. I have it hard when I moved behind the light board, one of the things I do is plug it into the directly
Uh-huh.
into the Ethernet. So I just unplugged it. We'll see if that fixes it. And then the other thing is yeah, thanks Epic, tra la la. So before SPIFFE, workloads may be communicated with service tokens. And what was the you're about to tell me, but what's the problem with communicating via service
Yeah.
tokens?
The problem is like somebody has to store those tokens, and typically,
Mm-hmm.
since developers are lazy and deadlines are approaching, and there's like other things to do, you put it into source control or you bake it into
Uh-huh.
the container image. So
Mm-hmm.
those tokens are there for any adversary, any attacker to just fetch them. Like if you have access to
Uh-huh.
source control, you have those tokens. Or if you can shell into the container somehow, or if you do some kind of an injection attack, and
Uh-huh.
get clever enough. And getting clever
Uh-huh.
enough is not that hard, because right now there are tools and workbooks and like things that help a hacker to hack a system as long as there's a no vulnerability. So keeping secrets around is not the safest way because like secrets have to be secret by definition.
Uh-huh.
So those, having a service to have to maintain a service key and identify itself with that key uh, causes that problem. Like if you go back to, you telling me turtle jelly bean, I forgot to, phrasing a secret. And if somebody overhears it and tells, hey, I'm Whitney. You don't look like Whitney, but I have turtle jelly bean. Okay, you are Whitney. Come on. So, that's the problem. Like that's the keeping those secrets, managing those secrets, rotating them, expiring them. Like all of them become a trouble, at least especially at scale, and that's where
Mm-hmm.
SPIFFE and SPIRE by extension solves it essentially.
What? And then you mentioned via MTLS and what the problem is with that. Let me just take a quick little see if I'm gonna plug in my Ethernet again.
Yeah, MTLS doesn't have any problem per se. It's
Uh-huh.
it's a secure way to communicate, but the problem
Mm-hmm.
with traditional before SPIFFE Spire MTLS is you have to manage certificates, and that certificates have to be signed by a certificate authority
Mm-hmm.
CA, and since getting back then, right now it's a little bit, you can have things like I forgot the name of it, but you can use the ACME protocol to dynamically refresh certificates. But typically back then, the lifetime of a certificate was long, in the order of years. And if it's like a higher root level certificate, it's on the order of tens of years. And that makes, expiring the certificate a problem. So, and if so, for example, if an evil attacker gets a hold of the certificate, then they can claim, just like telling the shared secret, they can claim to be another workload. And to mitigate that, there was CRL, certificate revocation list, which is a hairball in itself. How do you manage it? How do you query it? How do you keep it up to date and things like that? So MTLS in itself is good, but the management of certificates there was one of the problems. And like SPIFFE took it on top of itself, like how SPIFFE assigns identities to workloads is it does it without directly involving any network into the mix. So without giving a service key or a service secret, it dispatches identities to the services. And I'll go into how it does that, but before that, I think it's better to dive into access control. By the way, you are still flickering to magenta and back.
I'm a little distracted by it. So I think I'm going to try restarting my browser. So I'm going to jump off and jump back. So go ahead.
Do you want me to randomly chat or just continue?
Yes, please do chat. Well, chat randomly because I'd like to be here and record.
Okay.
Take a moment. You can sing me Moonlight Sonata. I'll be right back.
Alright, so what shall I chat randomly? That's fun. Let's see, I can dive into like my overall involvement maybe with SPIFFE and SPIRE community. Like I said, I have been in the community, since like 5-ish years, and it has been so fun so far. And we have a Slack workspace that is public. Anybody can join it, but it is not a paid Slack. So after 90 days, everything goes away. So like when you find something useful there, just copy it and save it around. Otherwise, it's went away. Pavarotti. My voice is not. I need to have a strong espresso before I can sing. Let's say it that way, because this stream is PG-13, I guess.
And it didn't fix it.
Okay.
Chat. I guess no, it didn't help. What do I do next? No, it's not better.
It's a little choppy.
Maybe I have to restart the light board.
It's not flickering, but I see like you seen by like a stop motion.
Now I'm gonna restart the whole light board setup. So so there is time for you to sing. If you just give me a few notes, I'll sing with you. How about Bohemian Rhapsody?
No, is this the real life? Come on, I won't. My voice is cracky. It's early, like in my time zone at least. But I can, let's see, not piano, but I'll just I just randomly going through my like stuff that I have wrote, because I don't just write technical articles. Sometimes I write about things that are the not so technical parts of being a leader, developer, you call it, and try to dive into those unwritten parts, because like your social skills are as important as your technical skills, especially when you're ramping up. And one of them is I recently wrote is like unlocking how you can learn things, the power of your not brain, but your memory, how you can learn things fast, remember things fast, and there are scientifically backed ways of doing it. And there are no secret, but still, they are important to keep in mind. Like one of them is like using visual aids. Like it depends, sometimes you can be a visual learner, sometimes you can be more like a listener or writer or a mixture of both. But a research after research shows that when you use an actual pen and paper and you draw diagrams, charts, images as your visual aids, it can assist you to like encode your knowledge in a way that this wetware understands and recites and stores in a permanent place. Otherwise, your short-term memory is like 7 items, if maybe 10 if you are really, really good at it, but no more than that. And those 7 items are, I don't know, I need to feed the cat. 1 item is gone. I am hungry. 2nd one is gone. I have a meeting. I don't know what meeting it is. Let me check my calendar. 2 more items are gone. So it's like really limited. It's brain is not efficient in the short term way, but in the long term, I don't know, you might have an interview with some company and you might remember like a theorem, let's say Nyquist-Shannon theorem that you learned maybe 20 years ago. It comes pop all of a sudden. But the opposite, it's also true, you have something like a song, the word of a song is in the tip of your tongue, and it doesn't come. No matter how hard you try, it still doesn't. Tyndall says, I live by to-do list these days. Yeah, it is like, I find it, writing things down is one of the ways to like unload your brain. But I circle back to, when that thing doesn't come, what you do is, there's a certain part of your brain, without going into any technicality, which I'm not a, neurologist, so I won't be able to anyway. That part of your brain, if you try to remember it hard enough, you overload it, like, I don't know, overclocking a computer maybe. So it gets overwhelmed and then you cannot remember it. So, but what happens is you forget it, you give up, and after 5 hours when you are in the bathroom just thinking like this and doing your thing, it comes up. And why? Because like in the background it was working and you gave that circuitry enough time to cool down. So the suggestion in there is to I don't know, do anything different than that actual task, like sing a song, watch TV, go out and walk. Nature is also a really nice stimulant in that case. Something major was stopping using a keyboard or to-do list. Oh, tablet. I have, where is it? I don't have it with me. A paper tablet called Remarkable. I'm not affiliated with it by any way, but it's like a paper-like feeling, but it doesn't have anything else on it. So you can just write and that's it. Oh, look, it looks like better. And
hello. Thank you for your patience.
I was giving a lecture on neurology, so you saved me.
I maybe saved the chat too.
Yeah.
Oh, bam! Just kidding. Hey. I'm so joking, so deeply joking. Okay. Yeah. Thank you for your patience, everyone. Woo!
Yeah, it's better.
I do this every morning. I restart everything before the stream to try to avoid this, but it's just a lot of plates spinning.
It's demo gods. It happens all the time.
Do you know what happened? Is right before the stream started, Volkan and I were talking, and we were like, "What's the worst that could happen?" And we just totally jinxed it.
Maybe it's better not I don't know, attract those minions by talking about them.
Exactly. That was our mistake. Okay, so I'm going to recap what we've talked about so far. Mm-hmm. I did hear a little bit of Bohemian Rhapsody, so I'm here. I'm here for that. So before SPIFFE, we have 2 workloads that need to communicate with each other. So that was done either with service tokens, but those need to be stored somewhere. Sometimes they get hard coded or injected into a container image, but hackers can extract those is the problem. Or you do it via MTLS, but that it can be done, but certificates have to be managed and rotated, and that could be a pain. So now that sets the scene for why SPIFFE needed to get created. Yeah.
And like before why, I'll dive into how. And then I'll
Okay.
dive into what, I guess, and then why. uh,
Okay. So what SPIFFE is coming up though. So we're gonna say
okay.
how. You tell
Okay.
me.
Okay.
Yeah.
How, like, to describe how, I think we need to talk about, what is what is a access control, because essentially what we do is controlling access to. Okay.
Can we
Are
say
we,
what before how?
okay,
How?
what? Okay, what
Yeah.
is SPIFFE? SPIFFE and SPIRE are two separate projects that is hosted by CNCF, and
Okay.
SPIRE is a CNCF. I think SPIFFE also is a CNCF graduate, because the one to graduate, the other has to, because it's one of them. SPIFFE is the standard, and SPIRE is the reference implementation. And the
Okay.
name of SPIFFE, it's a mouthful. Secure Production Identity Framework for Everyone. Maybe where is that acronym is coming from? What I heard, but I didn't ask to Joe directly. Maybe I can, DM him sometime. It was one of the first things that came to his mind. I think that's the beginning of the story, and there was a domain available, and naming things are hard. And also, it reflects the goal of the project. So that's how SPIFFE came out to be. It is the open source standard for. Actually, it's a body of standards. It has a bunch of other sub standards as well to securely authenticate workloads in a dynamic fashion in heterogeneous environments, so to speak. And like I said, SPIFFE is the blueprint, so it's like an interface. There are implementations of those blueprints, and as far as I know so far, SPIRE is the main reference implementation that has been used, that has been battle tested a lot. And like, when you cannot split them, so when you talk SPIFFE, you install SPIRE essentially, and SPIRE is the SPIFFE runtime environment. It's the most common, most battle tested, and production ready version, like I said. Let's see.
How?
Okay. Then. So that is what.
Wait,
So
I want to make sure you just said a lot, and I I want to make sure I paraphrased you correctly. So,
okay.
secure SPIFFE stands for Secure Production Identity Framework for Everyone. I
Yes.
like how inclusive it is in the name. It's a standard for securing and identifying workloads in a production environment. Is that
Yes.
correct?
Yes. It captures it, I think.
Okay,
Uh,
and then SPIRE is the reference implementation.
Spire is the reference implementation. It is tested at scale. Like
Wait, what's the is SPIRE an acronym too?
SPIFFE runtime environment.
Oh, that's less fun.
It's easier to
For
remember than
everyone?
SPIFFE. So secure production identity framework for everyone, runtime environment, but like it's SPIFFE runtime environment.
Oh, so here's the SPIFFE. Okay. SPIFFE
The
runtime.
runtime environment that's Spire, and it has really been tested at scale. Like, the largest Spire user, as far as I know, is ByteDance, TikTok. They have around 1 million million node Spire distribution across the globe. So if it works at that scale, it can
Wow,
pretty much
cool.
work at any scale, I guess. And I'm hoping it's not a private info that I shared, but I don't know. I'll claim I don't know that information if somebody asks me. But
Awesome.
yeah. So those are the definitions, and how does SPIFFE like dispatches identities to workloads, and to for that, it's better to get one step behind. Like, what is identity? What is access control? And access control is like you combine an identity with an action, like who with what, who does what,
Hmm.
and maybe a time, who does what around what time frame by when. And when you do who does what by when, it's like a project description, which it's I don't know. So like, when you combine who and what, who is doing what, it's like a policy, like an open policy agent-ish policy. And
Okay.
SPIFFE doesn't quite bother about the what part. So it
Mm-hmm.
establishes the identity, and lets the identity to be managed by things who know to manage those identities. One of them is open policy agent. It can be something else as well. And the who
So,
part is
oh no, it's doing it again. Can you back up a little bit for me?
oh
And so what? At first I thought I understood, but then you lost
uh-huh.
me. What's what plus what?
Who plus what? Who is the identity? Like, who are you?
Okay,
You are
okay,
Whitney. But the first thing is like, can I trust you when you say I'm Whitney? That's one thing, which I'll dive into that. And what can Whitney do? Like, can
okay,
you like just do any random thing, or you have a limited set of ability, like a access resource accesses that has been defined to you essentially. Like you cannot just go into, I don't know, president's house and have a coffee chat. You need to like have the access for it essentially.
mm-hmm,
So who and what makes the policy, and the policy is typically managed by policy managers and policy frameworks.
okay,
Open Policy Agent is one of those, but there are many. I
uh-huh,
give OPA as an example because it's the cloud native way of managing policies, but there are other versions as well. And SPIFFE likes to delegate the what part to policy managers rather than doing it itself, because it's a complicated identity is a complicated solution in itself, and SPIFFE and SPIRE wants to solve one thing and one thing well, and to me it
okay.
does it beautifully. Uh, so back to the identity part, and like maybe back a if you imagine like a, I don't know, a server setup or a data center setup, what you call it, there's the physical platform layer, the machine itself or the hypervisor, and on top of it
Mm-hmm.
you have the host, and on top of it you have applications, processes. In the cloud native era, it is like those processes are containers or pods, depending on how you containerize them. But essentially, it's on top of a host, and host is identified by essentially its IP address. So each host has an IP, so you can just go to like HTTPS IP address / API / something, and you can fetch data from that host. So the problem is, which layer shall you? I am talking, but are you?
I'm sorry.
I can go to neurology
Uh-huh.
again.
I think it's the port on my laptop, and so I just switched the camera, so it's now running through a different port. That's what I
Okay,
decided, and it seems to be working. So, um, yeah.
all
So
right.
I feel
So,
good about that. So sorry about that. I got
uh-huh.
distracted. I should have said I was distracted instead of letting you go
Yeah,
on.
then I was just going on, and I realized, oh, that you have in the behind the scenes part of light board. Oh,
so
okay.
so
Uh-huh.
what we have is like a policy is who and what. So we have an
Mm-hmm.
identity plus an action is a policy. And
Yeah.
then the policy itself is usually managed by a policy framework like OPA or Kyverno. There are many of
Yeah,
them.
yeah, yeah.
And then the action is probably managed by that
Yeah, it's
policy
action
framework
part
too.
of it.
So
And
the
identity
identity
is
part
managed
is
by
spiffy.
SPIFFE. Yeah.
Yeah.
And that begs the question, where shall we put that identity? And I describe, a typical uh, Docker or a Kubernetes setup. So you have the actual machine. On top of that, you have host OS, and on top of that, you have the processes. And those processes can be containers or pods, depending on your architecture, essentially. And
What are the layers?
one layer is the platform itself, like the
Okay.
machine. On top of
Okay.
that, it is the host, which you identify by an IP address. And on top
Okay.
of that, you have a group of, applications, processes, whatever you call it. And those
Mhm.
processes can be pods or containers, depending on what orchestration framework you use. It can be just, good old Linux processes as well. But in
Mhm.
a typical cloud native deployment, uh, everybody uses Kubernetes, and on
Mhm.
Kubernetes those are pods, but they don't have to be.
Okay.
SPIFFE is pretty much agnostic about what or where a workload is, as long as it can talk to an API and consume its cryptographic material. It's good to go essentially. So to put the identity, like you can put the identity in any of these layers,
Ah. Okay.
but it has pros and cons, because if you go down to the middle, things get, more substandard and more vague. So if you put a identity to the platform, it is something like, I don't know, VM ID, instance ID. Those are, you cannot share them because different architectures have different kinds of IDs. They don't play well together, and they are rather rigid. One level high is IP addresses. It's a relatively better way of identifying something, but in a cloud native area, IPs come and go all the time. You have to deal with hoops. Yeah, you need to do network address translation between IPs. Those NAT rules can change. Like, essentially, when you are doing something cloud native and you fix an IP somewhere, that's, to me at least, that's not cloud native in itself. So like, IP is not a way to identify because network grows and changes all the time.
Okay, so let me stop you to make sure I'm understanding where you're going. So what you're describing right now is identity can be added to any layer, right?
Yeah.
But you're kind of going through
from down to the upwards, yeah.
It sounds like you're going through why you might not want to add identity. Okay,
which I'll come to, why I might need to add identity to the workloads, which let me think.
Okay, so let me capture this. So,
okay.
Machine layer isn't great, and why is that?
And why isn't that great? Because at the VM or machine layer, they don't play well in a multi-platform, multi-OS scenario. It's those IDs, are not compatible. Essentially, it's not platform agnostic, and it is rather rigid. You cannot rotate a machine ID. It's there, and it's mostly there.
So machines don't play well with other machines, basically.
Yeah, mostly.
Okay.
And on the host layer, the ID that you use, I'm assuming you are going on above level 2. You are not dealing with Ethernet frames because then it will be insane. An ID that can identify a host is its IP address. So if you have 192.168.1.5, then I know that you are in a machine with IP 192.168.1.5. But in a cloud native scenario, that doesn't play out well as well, because the network can change, can shift, can grow, and managing those IPs in a distributed fashion becomes a pain. And in a federated setup or a hybrid or a interconnected, cross-cloud setup, you have to deal with what's called NATs, network address translation definitions, rules to capture an IP, capture a packet, translate it to some other place, and you need to do those IP address translations, and it becomes a burden essentially. And that's why in a cloud native pattern, you don't go with the IP. Typically, you choose DNS essentially. But in any rate, even if you use DNS, there's at the host layer, there is a lot of churn and change, and you have to distribute those churns and changes rapidly. That's a problem with the host layer, which when I'm in that position, if I'm trying to solve this and nobody has solved it and I'm trying to invent it, I think at that point I will back up a little. Like, what I'm trying to solve, what entities are trying to communicate, not hosts, not platforms, definitely. The process is Whitney can talk to Volkan. That's the policy. Not Whitney's host can talk to Volkan's host. I don't know. I imagine two of us are riding horses, and we don't want our horses to talk. We want each other to talk essentially. So that's and that's the concept of identities needs to be securely dispatched to workloads without needing to rely on the network, because from a zero trust security perspective, network is always breached. Network is not secure. You cannot trust the network.
I have a question.
Yeah.
And this is semantics, but is a workload and a process the same thing?
Yeah, that I get the question a lot. Workload is just an application, service, process, the same thing.
Okay, so it's best to add identities to processes.
Yeah. And like one way to add identities is like we talked. We can give a secret key to the workload that will be its identity, but in
Mm-hmm.
that case, you have to secure that secret key. Like you can think, you can encrypt the key and keep it
Mm-hmm.
the encrypted way, and the workload can decrypt the key with this encryption key and then share it securely. But in that
Mm-hmm.
case, where do you secure the encryption key? You encrypt it again with another encryption key, but where does it go? Like, and
Yeah.
that's the turtles all the way down analogy,
Uh-huh.
I can say.
Yeah,
Uh-huh.
it seems related to like certificate hierarchies too. Like,
Hierarchy, like
yeah,
who
yeah.
who owns the key to the kingdom, who like
Uh-huh.
maintains the master key. And like I'm reflecting this image like turtles on top of each other. uh,
Uh-huh.
so it is like it is, I think it was first coined by Bertrand Russell, the philosopher, and
Uh-huh.
in a lecture of a cosmology of his, an elderly lady claims that the world was regularly flat on a flat plate, supported by like back-to-back stacking turtles. And then Russell asks, where is last turtle standing on then? And the lady says, "Yeah, you seem like a really clever man, but you are wrong. It's turtles all the way down." So it's the turtle analogy, turtle story, and it's similar
Mm-hmm.
to it reflects to how you can secure a secret, in a sense. Like if you encrypt the secret with another higher level key, then you have to secure the key. If you encrypt that key again, you have to secure the key that secures the key, and it will go ad infinitum to like forever. And to sort that out, one way to do it is to I do use the matrix analogy, is that in that way there is no spoon. Like if you assume that there are no secrets,
Uh-huh.
then you can, like if you don't have any secrets to manage, then
Mm-hmm.
you can distribute identities to workloads without having to deal with secrets. And uh, so how do you do that? Like how does it done in a physical world? Like how do I prove my identity? How do you prove your identity? And we have like the paper booklets called passports. Passports are given by an authority, and
Uh-huh.
passports are designed to be not tampered. And if you share your passport with someone else, that's illegal. You'll go to jail. So in that regard, passports introduce the concept of attestation. Like when a passport is issued, it is attested by an issued authority. It's the government, and typically you have to prove that you are you. Like you come with a bunch of your birth certificate, your picture, your whatever, and the authority physically sees you and say, you look like Whitney, and you prove that you are Whitney. Here's your passport, and I signed it. There's a filigrant on it. You can go and scan it with a UV filter, whatnot, and that proves you. And you don't need to keep a like jelly bean turtles hopping around secret to prove that you are you. Like that passport is a key essentially. It doesn't. It's public information. Doesn't contain any secrets. And SPIFFE IDs, in that regard, the SPIFFE IDs that Spire distributes is like digital passports for workloads in a sense. And how does it this is okay? I'm listening.
A couple of things. I want to. Thindle has a story about
CAs.
CAs or lack thereof. Yeah, tell your story, Thindle. And then
Yeah.
I want to. You're talking quite a bit, and I just want to jump in and make sure I'm
Mm-hmm.
following. So we're talking in general about how it's best to add identity to processes, but
Yes.
then how is that done? And in the past, when we talked about the past, it's been done with service tokens, but then you need other service tokens to verify
Mm-hmm.
your service tokens, and it's turtles all the way down.
Yeah,
Or
yeah,
you
yeah.
do it with certificates, where you need some certificates to verify other certificates, and again, turtles all the way down. And that's
Mm-hmm.
not the best way to do it, is what we're saying, right?
Yes, yes, yes.
And so
And
now we're
uh-huh.
jumping into how SPIFFE does that without using
Yeah, yeah.
turtles all the way down.
how can I know you that you are you without you
Uh-huh.
saying me a passphrase or without I trusting your word? I trust your word, but we are friends. But still, there
Uh-huh.
needs to be a cryptographically secure way of establishing it. And a workload cannot trust a workload. Essentially, it can, but it will be mayhem. Because trusting without validation is like public access, basically, and that brings up the concept of attestation. So there are various
Wait,
ways to
so what we're talking about now is how does SPIFFE
how does
create
SPIFFE
an
how
identity for a workload?
how does SPIFFE create an identity for a workload?
Okay.
So attestation. Actually, before that, I rewind a little bit because I need to give some core building blocks and like what SPIFFE does and what SPIFFE uses and the key challenges as well.
So
So,
wait, before you
uh-huh,
jump in, a couple of things. I want to say
yep.
hi to Thindle and hear his story. But
Uh-huh.
also, are we going to talk right now about how does SPIFFE create an identity for a workload, or are we doing other things?
We'll get back to it after I talk about what SPIFFE's key challenges are essentially.
Okay, so that's what. So, and when you say key challenges of SPIFFE, we're just talking about these are the specific problems that SPIFFE is designed to solve,
Yeah.
right?
I'll talk about these are the specific problems, and each of these problems have a standard documented how to solve it, and you cannot solve those problems by just randomly jotting things down. Every problem has a specific standard that is associated with it that you can dig into from one of the links that we shared at the beginning of this chat, essentially. So
Okay,
one,
let me say hi to Thindle real quick. Thindle,
yep,
uh, had a payment provider that used self-signed certificates for
uh-huh,
security,
yay,
not just identification, actual security. So no way of checking them. Just just here, I promise. It's me. I promise it's me. And they deal with money. So
yeah,
yeah. Um, so Thindle had to disable the security for the HTTP connections.
oh,
Okay.
fun.
Yeah.
Or funk maybe with PG-13. Okay,
All right. So
so
we're going to talk about these problems that SPIFFE is specifically designed to solve.
uh-huh.
Cool.
Okay, so the challenge is first of all, the format of the identity. You need an identifier, and you need to
Uh-huh.
have a agreed upon standard on how to name that ID, which is described by the standard called SPIFFE ID. So SPIFFE ID is like a URL. It starts with SPIFFE :/ and the rest is like a typical URL, example.com /something else / it goes it's like a web address essentially. That's the ID, but just the ID doesn't prove
Is
anything
it
because it's
is it
SPIFFE :/ and then the rest is like the domain name, which is the
Oh,
trust root.
yep. But it says SPIFFE ID. Is it like all one word? Is it two words?
One word, spiffy, and then :/ then whatever,
Uh,
I don't know, example.com something anything can /go /here. So anything can go there as long as it looks
uh-huh.
like a URL. You can even put a UID if you don't want to format it or partition it. But if you partition it in a clever way, then you can use it uh, SPIFFE ID / production / service account name / workload name, something like that. So you can logically categorize it to make it meaningful to yourself. But from
Uh-huh.
this point of SPIFFE, as long as it is uniquely identifying a workload, it is good enough, and as long as it follows the SPIFFE ID standard, essentially. But
Okay.
the ID in itself doesn't prove your ID is Whitney, but are
Yeah.
you Whitney?
Yeah. Who knows?
Maybe, maybe not.
Yeah.
So you need a way to prove that identity, because, like I said, identity without authentication is just public access, and it's not good in a secure network.
Uh-huh.
So for that, there's a bundle construct, which is SWIT, SPIFFE verifiable identity document. And SPIFFE verifiable identity documents are signed documents that can prove that a workload is what it claims to be. And once you have SWITs, the next question is, okay, but how do I trust the workload and give SWIT to these workloads? Because the workload doesn't have the secret key, because we are trying to eliminate the secret key from the beginning. So
I have a question though. So the SPIFFE verify proves that a workload is what it claims to be. But what format is the?
The format is SWIT as SVID, SPIFFE verifiable identity document.
It's a document. Okay, like a text document.
Like a chain of certificates.
Okay.
And you can also write the acronym, I guess, S because it's S, then V as in Victor, and I and D. Yeah, SWIT. So SWITs are like a group of certificates and keys that can. When you give it to the workload, then workload can say, "Hey, I have this passport. You can trust that it's me because somebody gave it to me." But how do you give it secure? Like, I cannot just distribute passport to everyone that comes to me and ask for a passport. Like, I need to attest the actual identity of that workload or that person. Like, if I am the government, I do this in a formal process of I want your birth certificate, I want your picture, I want your whatnot to attest that you are you. And in the workload case, there needs to be a way to obtain these SWITs, and that's through the workload API. That's the third key challenge that SPIFFE is trying to solve. So it exposes SWITs, the workload API exposes SWITs to workloads. And from SWIT, you can extract the SPIFFE ID as well. SWIT proves that, like, if the SPIFFE ID is Whitney, then SWIT is a seal, I don't know, like a wax seal that is not tampered. So you can just open up the seal and there's a letter inside and nobody has opened it because I know that it is sealed and the seal has the, I don't know, insignia of the queen. So I know that it is assigned by me, by the queen, essentially. So that's done by the workload API, which exposes SWITs to workloads. And the way the workload can get SWITs from that workload API is to attest itself. And that's the point that I was trying to come before, but right now I'm coming. But I had to, define these key challenges beforehand. And each of these challenges have an associated specification, and they are relatively easy to read. I read them before. It's much easier than, I don't know, like ECMAScript specification or some other weird language specification. It's followable. It's understandable. So that's that one. But how? Oh, come on! My notes are fading away. I get them.
We jinxed it. We jinxed
it. So, how can you dispatch those identities without the workload providing a secret? Because the workload doesn't have anything to it just came into existence. Hey, it says, hey, I am a workload. I am talking to the workload API. Who am I? And it doesn't have anything to give to prove because the passport is not there. And to dispatch that passport, the workload API introspects the system, and the system can change. It can depend on where the workload is deployed or built. So if the workload is a Kubernetes pod, then workload API will talk to the kubelet and get information about the workload that's asking questions. So it'd say, okay, I kind of know you, I guess, because I know that you have this service account. I know that you are in this namespace. I know that your workload name has this substring. All of these combined, I can I can assert that, or I can attest that you are who claim you are. Then it dispatches a certificate. If there is, if Kubernetes is not there, like if it's like a AWS EC2 instance, then it will talk to the cloud provider's API. It will say, hey, your AMI account name is this one, and you have these policies applied onto you, and I know that you have these labels. I can even read your init script and like parse it if I want to, and based on those, I know that you are this this virtual machine that is in, I don't know, US East 2 region, because I can query the orchestrator, or I can query the hypervisor. Or another instance, like there's no cloud, nothing, it's bare metals data center, and in that case, workload API, or actually the SPIRE agent, can talk to the operating system itself. It can read the process's process ID, or the user account that's running the process, or the permission list that the process has, or like it can query, like it's indirectly like like the workload API. Not workload, it's the SPIRE agent, to be specific, but I call it workload API for simplicity. But that part indirectly queries what is around the workload to get a cryptographically verifiable concept of the workload to trust it. So it can even check you can provide the SHA hash of the binary, and it can verify the SHA hash, like, hey, when I hash the binary, I get the same signature. So you are highly probably the same thing, because if you change one bit, the hash will change essentially. So
Yeah.
So indirectly, it attests the workload and ensures that the workload is what it claims to be, essentially. And that way, it can dispatch SWITs, which are none other than X509 certificates, essentially, to the workloads. And then workloads can say, hey, I have a certificate, and I can claim that I am myself, and I can use that certificate to talk to other workloads that have a similar certificate, and then establish a MTLS, mutual transport layer security connectivity.
Can you hear me? Yes.
I can hear you. I don't see the light
Yeah,
board.
I think it's a problem with the ports on my computer. I'm gonna restart right now. I'll be right back.
All right, I'll go back to using visual aids and pen and paper. Okay, so another thing that helps. This is a weird stream, but I like it. I like the format. Another thing that it helps to like jog your memory is to like they do it in groups, like they demonstrate it and engage it in a group discussion, because like participating in learning through demonstration, like right now, like I'm trying to teach something by simplifying it, and it helps me to like tighten the concepts in my mind to clarify, because when you teach, you'll know what you don't know as well. Like that's also like sharing what you know. For me, it works 100% of the time. So the typical approach, the Feynman technique, is like you choose a concept, you try to teach it to a child, and try to increase the level gradually. Then while you teach it and add more verbosity to it, you try to identify the gaps in the. I don't know. I see teaching as a storytelling as well. You identify the gaps in your story, and then you back it up with either extra information or source material, and then you circle back, review, and simplify. That's one way to really, really learn something. And the other is to connect a new material with what you know already. Because like establishing connections between information that you know, and the more unusual those connections are, the better. Can I can I pause my lecture?
I'm gonna have to rewatch this video so I can get the neurology lecture.
This is like playing the piano, actually. Like I'm splitting my brain, switching to neurology, back to SPIFFE, then back. It's fun.
So let me summarize what you've told me so far and make sure I'm with you properly. So we have this thing called a SPIFFE ID that's a standard for formatting an ID, and it looks like
Uh-huh.
URL. And then we have this SV ID, a SPIFFE verify ID. So
Verifiable
that
identity document.
oh, I want to write that. Uh, SPIFFE
SPIFFE
verifiable.
verifiable identity, and those acronyms are SPIFFE verifiable identity document. I
Oh,
have to note them down to tell them correctly. I mix them up all the time.
alright.
And I typically call them
So
SWITs, you know. But that's the issue, I guess. Like when you are in the SPIFFE community, when you say SWIT,
uh-huh.
everybody understands that it is an SWIT.
Yeah,
But for somebody, you know, who's just jumping in, it's
like
better to
yeah.
clarify, like yourself. Yeah, yeah, that's
um.
one. Uh-huh.
Okay, so SPIFFE. So we have this SVID, SPIFFE verifiable identity document. So
Hmm.
this proves that a workload is what it claims to be. It's like a driver's license for a
Yeah,
workload, but it's a bundle of. It actually is a bundle of certificates
yeah,
and
it's not
keys.
just a single file. Say a chain of certificates, private key. It's in a certain format. I need to read it to dive into details, but then I don't need to, I guess, because it's complicated enough. But like a driver's license to at a high level. Yeah.
And so a workload API verifies the SVIDs, SVIDs to
Hmm.
workloads. Does that mean it gives, can I say it gives SVIDs to workloads?
Yeah. It after attesting the workload by
Uh-huh.
querying what's around the workload. What's around the workload can be the operating system, the Linux kernel, the orchestrator like Kubernetes, or the cloud provider's API. After querying those and getting enough information about the workload and attesting those, because like to define a workload, you first need to register that workload to Spire, and there are automated ways of doing it, and also there's manual. You can just dive into shell into Spire servers CLI and say, hey, I want a workload that's called, I don't know, database server, and that database server has this service account, this username, this account name, it is in this namespace, and it has these labels. When you see it, give this password to it, because I, as a, service administrator, tell you that it is this workload. I trust it. So that can be done manually. First, when you register the workload, then Spire, when you coincides with that workload, talking to the workload API, it can dispatch the identity, because it proves that what it's searching has a matching uh, list of criteria that matches the workload itself. So,
So, so, so first, so the workload API gives the SVID to the workload, but
mhm.
first the workloads test themselves. So they say, this is who I am to
Yeah,
gain
it's a
access to the workload API. And then
yeah,
the
it's
workload
a
API will verify that by
mhm.
using other stuff in the environment. It seems pretty
Yes,
smart, actually. So
it
it
is like
might query
it
the
works.
kubelet, it might talk to the operating system,
Uh-huh.
it might check the SHA hash to
Hmm.
make sure that it feels right, but it'll do one or many of these things to make sure the workload is what it says it is.
Yeah, like I kind of visualize it. Where are my turtles? These are my turtles. So I
Uh-huh.
visualize like the bottommost turtle flipping over, like on its shell, like supporting with
Uh-huh.
its feet. So right now, there's no secret, because it's you are querying the, I don't know, the platform to know about the workload without needing to the workload
Yeah.
to prove itself, which is genius. Like I thumbs
Yeah.
up Joe Beda, by the way, like for coming up with the
and
idea. Yeah.
and so at that point, once it's satisfied, does it then it issues this the SVID?
Yeah, you should. A bunch of things like issuing is, if it's just issuing, you can like get away with using a good old certificate and call it a day. Why
Mm-hmm.
implement this entire public key infrastructure managed by Spire? So each issues
Mm-hmm.
rotates, revokes, distributes, and also compartmentalizes. So you can create different trust domains that can, like, an S within this domain cannot be legible in another domain. So those are a bunch of things that it
Okay.
does, along with just giving the S with. And do I
Okay.
do you want me to list them again?
I do, but I want hold on, please.
Mm-hmm. Oop.
So So once this process is complete,
Uh-huh.
is when this happens.
Yes.
Okay.
Oop.
Then our workload API issues. Okay, what does it
Actually, it's
issue?
the let's scratch the workload API, because the actual thing that issues the certificates is the SPIRE server. So SPIRE server, maybe I don't know. We are running out of space, but SPIRE server talks to SPIRE agent, and SPIRE agent exposes a workload API. That's how the chain of actions go. So those are the main components, I guess. So SPIRE server issues SWITs to agents, and agents expose those SWITs through the workload API. So by proxy, you can, if you want to keep things simpler, you can say workload API issues. I think that's fine enough, at least for
Okay.
any.
We can put what you just said here so we have it on the board.
Uh-huh.
But Spire, we repeat what you just said. Spire
Spire
server.
server talks to Spire agents, and Spire agents expose their workload API.
Okay.
So maybe an arrow from server to agent, and then agent has a workload API.
And then each Spire agent has its own workload API.
Mm-hmm.
Okay.
I can get into more details, but we are running out of space anyway.
We are. And
But
that's
yeah,
how, okay.
how the workloads get their SWITs. But since this is like it feels like a causal relationship, or like this does that, like if A does B to let C do it, then essentially A is C by proxy. So we can at a really high level say that workload API does all these. I sometimes like simplifying, even if it doesn't make quite technical sense, to make it clear. So in that regard, workload API is responsible for rotating, revoking, distributing, and compartmentalizing the SWITs.
Also, rotating,
Rotating, revoking, distributing, and it's hard to say, compartmentalizing. And that is like the what and how. And from that, I'll jump into so what, I guess.
And is it like okay. So in this case, like in our story we're telling, it's just one SVID we're talking about. This one workload has asked for an SVID. Okay.
Yeah. And with that SVID, that workload, if two workloads have their own SVIDs, then they can establish secure communication between each other. And then they can exchange whatever secrets they have, if they have, or whatever information. So they claim that they are who they are, but this is just the authentication part. The authorization is not SPIFFE's problem domain. For authorization, you need to it can say, hey, I am the client, I am talking to the database server, I want to execute this SQL query. But the database server then can talk to the policy agent and say, okay, you are who claim you are, but you are not allowed to access here anyway, because I didn't grant you, or the admin didn't grant you some privileges to do it. So although it can prove itself, it still needs a second layer of validation that's done by either policy framework or RBAC or ABAC or whatever to do something meaningful, as long as you want to establish some level of control over the system. But the identity part is solved by SPIFFE and SPIRE.
Oh, okay.
Okay. So that's one
So,
SPIFFE, one SWIT. Yeah.
so two workloads establishing identity and having a secure connection.
Mm-hmm.
That's something that used to be done with like service tokens and MCLS.
Mm-hmm.
And what's good about doing it this way, um, is that you don't have to have this certificate hierarchy. Instead, we have this workload API that can
Uh-huh.
query the environment, and that's
Yeah,
how
behind the
the
scenes, you still
identity
have
is.
the certificate hierarchy. SPIRE server is the certificate
It's
authority. You can link that SPIRE CA to a like an actual trusted CA as well, which typically is not recommended if it's inside the cluster. But like
okay.
Spire handles all of them in the background behind the scenes, so you are not aware. Like you to workload, it is just I have this SWIT that somebody gave me. I don't care who gave it,
Uh-huh.
but I can use it for a while that it is valid. And the
Uh-huh.
for a while that it is valid is also like since this can be automated and be done at scale, those SWITs are really short-lived. The default on Spire is
Uh-huh.
configured to be like 24 hours. So even if somebody steals that SWIT, it's like 1 day time frame instead of months to years. So it makes
Okay.
it much more secure as well.
Okay.
But yeah, that's also
Cool.
like, what's the benefit? Like I'm trying. I see that you're trying to coming at
Yes.
that we
Uh-huh.
so what question. So
Uh-huh.
one thing is no more secrets. Neither your platform nor your workload needs to inject any secrets anywhere, including the source code. And as a result, we establish a sophisticated identity plane managing all of these rotation and revoking and distribution stuff, which is not easy. Like if you have dealt with certificates in any way, shape, or form, establishing a nationwide identity control plane that rotates every day is not an easy task. It's challenging beyond reason, and
So
also.
wait. So you're ahead of me. So benefits
Yeah,
of
yeah.
Spiffy.
Okay, so benefits
Yeah.
of SPIFFE. Neither your platform nor your workload need any kind of secret to be injected at deploy time, anytime, because there is no secret
Oh,
to deal with. Like that's the spoon part. There are no spoons. There is no spoon. So
yeah.
I like analogies.
Yeah.
As a result of that, like,
Workload.
or as a foundation of this is like we have the identity control plane that is done by SPIFFE in a way that otherwise we have to manually manage, and it will be hard to manually manage millions of identities at scale. So like if you have just two workloads, five workloads talking to each other, you can go crazy with good old certificates, but SPIFFE brings up the benefits, especially at scale, at a like more than a couple of like if you can not count your workloads with your fingers, then it's time to SPIFFE, I guess.
Mm-hmm.
We
Um,
But did we stop the leakage of secrets because like there are no secrets? Uh, and also the best thing is this is standardized, and it is cross-platform. So we broke down the barriers between platforms, clusters, cloud providers, on-premises deployment, and things like that. So I tested a proof of concept. Right now, it's not available to me, but I put one component to AWS Cloud, another to Azure, and they were happily talking to each other and securely connecting without having to deal with each of the specifics of those platforms. Because SPIFFE has a attestation plugins for all of those platforms themselves, so it abstracts the identity part, so you don't have to learn five different platforms APIs to just deal with identity. And also I would say we mostly negated the need for secrets management, because why a workload in your system needs a secret when it can cryptographically prove itself? You don't really need those secrets anymore, but there's a caveat there because we still need a cloud native secrets management solution that will be the discussion of a later talk maybe. But in that regard, SPIFFE at least brings up the foundation that you can build or connect to secrets manager solutions by using it as an underlay, essentially. And the other thing I told was, the certificates are short-lived. So it's in an unlikely scenario that an attacker gets a hold onto it. They won't have that much time to exploit it.
Mm-hmm.
Oh.
More secure.
Mm-hmm. Oh.
So I want to make sure I captured everything. And Thindle has a question too.
Yep.
So neither your platform nor your workloads need certificates or tokens anymore. So there is no spoon, you said.
Yeah.
With SPIFFE. SPIFFE manages a potentially complex cross-platform identity layer. And you don't need to worry about it. SPIFFE does it instead of you doing it.
Yeah.
There's no more need for secrets management. And short-lived SVIDs are more secure.
Yeah.
Is there anything I should add to that?
It captures most of it, I guess. If anything bumped to my mind, I can, let you know. Tyndall's question, Tyndall says, did you have to set up anything special regarding networks, VPNs, gateways, and the like to get the communication security working between the two clouds? From the perspective of SPIFFE, network is breached. So you don't have to secure. Like, if you secure, it's better because, like, security is a layered cake. You cannot just trust one thing. You need to build layers on top of layers of security. Like, I don't want somebody to hack someone's SPIRE server and get all the certs to, establish unwanted access. But from the security threat analysis of SPIRE or SPIFFE, it doesn't trust network. So network can be like just public access, but with the dispatching of SWITs, the security will still be established. But I don't know, if as a network architect you are not out of your mind, you'll put some level of security. At least you'll secure the ingress, if not the inside network. So a basic level of network security is nice to have. I would say highly recommended, but not necessary.
And then does it happen entirely transparently and you only need to open the ports for your application?
SPIFFE SPIRE doesn't deal with ports, so you need to establish network connectivity between the applications however you can. The rest is managed because if there is no way to deliver those SWITs, you cannot, you cannot magically cross Ether if it is, blocked.
Okay, got it. Cool. I'd like to understand more the SPIFFE SPIRE. Like, is this help to determine scope or limit scope? Like, why is this server and the agents and the workload API necessary or part of it?
Not to limit the scope, but I think to separate the concerns or share different responsibilities to different actors, essentially. Because SPIRE is more like the storage that stores all of those, certificates, keys, and whatnot, and then it delivers to the agents. And from a Kubernetes perspective, SPIRE is typically, you can do it different ways, but SPIRE server is typically a stateful set, and the agents are daemon sets. So you have one agent per Kate's node. So that's in that way you can have a centralized SPIRE server somewhere that all of the agents in different nodes can talk to. That kind of distributes the responsibility versus like having if you make every agent also a server, then you'll have to deal with maintaining a distributed database of those certificates, which is not an easy task. So having a centralized SPIRE server helps in that regard, and also it helps performance and caching, because the benefit of this architecture is like SPIRE regularly dispatches those certificates to the agents, and if the server crashes and doesn't come up to half of the certificates TTL, so if it is like
Every time you say certificate, do you mean SPIDs?
Yeah. Every time I say
Okay.
certificate, it's SWIT. Like
Okay.
like if the SWIT is going to be alive for 1 day, the server can shut itself down or get disconnected or evicted for half a day, and the system will still work because agents have the cached versions of the former certificates, and also
Okay.
workloads cache those certificates from the agent using the workload API as well. So the system is designed to be robust and resilient. So even if you kill SPIRE server and SPIRE agent for a while, things will work and nobody will realize that something is broken. They'll really realize when they need a new cert, but they cannot fetch it. But that time is like by default is half a day. And if your system is down for half a day, then you have bigger problems than SPIFFE and SPIRE.
So your SPIRE server is typically a stateful set, and it's software that stores and distributes the SPIDs.
Let's see. Can you repeat?
Is that correct?
SPIRE server is a stateful set. It distributes SWITs to SPIRE agents, and SPIRE agents are daemon sets, typically. Like, it doesn't have to be.
This is funny because Roy says debugger. That was a nice one. I think that's really funny since that joke happened an hour ago.
Yeah,
I love it.
Feel free to steal love to have my open source debugger franchises. If you become successful, then send me some cut of it. Why not?
So the SPIRE agents receive SVIDs from the SPIRE servers and do what?
SPIRE agents, they expose a workload API that the workloads can question. And the workload API is like a workload asking the SPIRE agent, hey, I just came up. Who am I? I don't know myself. Like, can you give me my name? And then the SPIRE... Oh, I shifted back to Aragon. Do you want your true name or the actual common name? But that's totally behind the... like, we don't want to dive into fantasy novels and dragons and whatnot. So the SPIRE agent, after attesting the workload, will give the SWIT, which is the identity of the workload in a high level, to the workload.
Okay. So it actually does expose this workload API, and it does the work of giving the SVID to the workload.
And there are ways to talk to this workload API, and there are you can use this in a Kubernetes environment. You can use a sidecar that does this heavy lifting and queries the SPIRE agent and then attaches your SVIDs to a in-memory volume, so to speak. Or there are SDKs. There is the most common one is a Go SPIFFE, because if you use in a cloud native way, Go is typically the way you go. But there's a Java SPIFFE. There is a recently created SPIFFE Create, a Rust SDK. There is a relatively outdated because it's a hassle to deal with certificates in Python, but there is PySPIFFE. So yeah, and there's also C SPIFFE. So Go, Java, C, Rust, and Python are supported languages that you can use if you want to programmatically query that workload API as well.
Nice. So I'm going to reread this. So a SPIRE agent is typically a daemon set. It receives SVIDs and exposes a workload API. It does the work of verifying workloads and giving them SVIDs. Is that correct?
Can you read it again?
A SPIRE agent is typically a daemon set. It receives SVIDs from the SPIRE server and exposes the workload API. And it does the work of verifying the workloads and giving them SVIDs.
Yeah, it's perfectly captures it.
Great. From server. Cool.
There's a question: how is that API securely exposed? That's the beauty. There's a meme, like the two gamers talking. Hey master, how when will I, start being a master like you in the game? And the other person says, that's the fun part. You'll never. Like it's the API is insecure by definition because you cannot maintain an identity of a workload without giving the identity to the workload. So workload will ask the workload API, and the agent will query what's around the workload. It can query the kubelet, or it can query the platform's SDK, AWS SDK, or not SDK, sorry, API, or it can query the kernel parameters like process ID of the workload, or the user group of the workload, or like I said, SHA hash of the workload to ensure that the workload is what it claims to be before dispatching the ID. But other than that, there is no network level security. It feels insane, but that's the beauty of it.
So we're filled up on the board. Are there any major points that you feel like we missed that I should write, like maybe where my face is?
Let me think. We talked about the SDKs. There are a bunch of tools and systems that use SPIFFE, and probably you have covered a bunch of them in your shows as well. Like for example, that's why you mostly you may be using SPIFFE without knowing it. For example, service meshes like Istio uses SPIFFE. Although I would debate that the SPIFFE ID they use is relatively rigid than what I would like to have, and there are open issues about that. But still, it is SPIFFE compliant. AWS recently, I forgot about AWS, but I can talk about Azure and GCP. They recently decided to establish their identity control plane using SPIFFE. Cert Manager CSI driver uses SPIFFE protocol. HashiCorp's Consul and I think Nomad, but I'm not sure, uses SPIFFE. There is a project called Dapr, DAPR, that is SPIFFE compliant. There are a bunch of projects that already use SPIFFE that you might be using without being aware of it all the time. Google claims that they are going. Taniwa in chat says, "I heard Google claims that they are going to start using it in the last Google Night." Yeah, and that was a really. I won't dive into my story because first I would like to have it in a separate session, and secondly, it is more Broadcom specific, and we are talking open source. But in my case, I was blessed to hear that because I have a secrets management solution that is backed by SPIFFE, and SPIFFE being used everywhere means, hey, I can talk to some department's VP and say, hey, why don't we use it instead of using that? Because this is here, it is there, and and SPIFFE is getting more a reception globally. That's that thing. Let's see, integrating with other systems. We talked about OPA, Open Policy Agent. So authorization SPIFFE explicitly doesn't solve and leaves it to other solutions essentially. What else? I can quickly dive into scalability, but I'll just list topics. I won't dive into description of those topics. You can scale a SPIRE architecture by doing horizontal scaling, a nested topology. You can do federated SPIRE deployments. That's pretty much how you scale, I guess. And security is...
And we can just say it scales well.
It scales well. We don't have that. Okay. And there is its documentation is nice as well. You can dive into spiffe.io and find documentation about production usage and how you can deploy those topologies depending on your platform's needs, essentially. And security is typical. Like you need to have a secure configuration. You need to know what you attest because you can, if you do your attestations incorrectly, you can dispatch random identities to random places, which won't work, or which will work, but it won't serve a purpose. Let's see. You need to have monitoring and auditing as any secure system. That's fun. I can dive into some feature of SPIFFE.
We have a question from Taniwa. Hi, Taniwa. Good to see you, friend. KMS support.
KMS
What's KMS,
support,
first of all?
key management system is Google KMS, right? Or it depends on AWS KMS, Google KMS. It's like a key storage. I think I have read somewhere, but I'm not sure. You can use a KMS solution as an upstream to SPIRE server to store the core cryptographic root keys, so that you don't have to store them in your box. It will be in the cloud in that key storage. So it can be, you won't have to deal with securing the trust material of SPIRE itself. So in short, it does have support. If you realize it doesn't, go to spiffe.io, raise an issue. I'm sure people will love to tackle with that. Yeah, that's that. Other than that, I have future. So there is a work stream going on, support for serverless workloads, because so far it was just regular workloads that are long living, but serverless is on the design board, so to speak. There is a work on integration with Cilium. There is some work, I quite don't remember, but there's some work around confidential computing, like SPIRE working in a confidential computing environment to enhance the security of SPIRE operations. And there is a assertion and tokens work group that is led by Evan Gilman to define more easier to use identity standards, and it comes with its use cases. It's going in its way. But yeah, those are future work items that the SPIRE as a project is working on.
That's you're aspiring to, huh?
Yeah, I guess.
I'm sure you've heard that a million times. Yeah. So if you're feeling ready, what I'd like to do next is I'd like to recap everything you've taught today that I have captured on the board anyway, to make sure that everyone, including myself, has a good understanding. And so now, folks in the chat, if you have any more burning questions, please ask them now. And then after we go over the recap, we'll do a little dance at the end to say goodbye. I'll replay the theme music and we'll dance our way out of here. So do you feel ready for that?
Yeah, sure.
Yeah? Cool, let's do it. And then again, chat, if you have questions, now's the time. So before SPIFFE existed, there were definitely workloads had to communicate with each other, but they often did this with either service tokens or they did it with mutual TLS or MTLS. So with service tokens, those need to be stored. They're sometimes hard-coded or injected into the container image, and hackers were able to extract the tokens. And then if it's MTLS, you have to deal with certificates and storing and managing and rotating certificates, which is a pain. So then we have the problem of the turtles all the way down, like tokens are used to verify more tokens and certificates are used to verify more certificates. So those important ones at the top of that pyramid if they're ever compromised, you're in trouble. So along comes SPIFFE, which stands for Secure Production Identity Framework for Everyone. It's a standard for securing and identifying workloads in a production environment. So two things, securing the workloads and identifying the workloads. SPIFFE, SPIRE is a SPIFFE runtime environment, and it is the reference implementation of SPIFFE. So when we talk about
actually, it is not the reference implementation. It's a reference implementation, but it's the most well-known, and I don't have heard of a production-ready other reference implementation. So, like other tools like Istio offer SPIFFE compatible implementations. So by extension, you can say they are implementations. But SPIRE is like if you go all the way to just SPIFFE but not leverage any other tooling, then it's mostly SPIRE essentially.
Okay, thank you.
Mm-hmm.
And so if we talk about two different workloads talking to each other, we talk about like who is the workload and what are they trying to do. And
Mm-hmm.
so Spiffy's talking about the part that's identity, like who's the workload. The parts of like what they're trying to do and whether they're allowed to do it according to your company's policy. There are other tools in the ecosystem, usually like policy tools like OPA or Caverno or something that
Mm-hmm.
manages that piece of it. So SPIFFE is the parts that does the security with the identity specifically.
Mm-hmm.
So we talked about all the different layers of the system, like the machine layer, like VMs, the host layer, Kubernetes, their pods, their processes. So identity, you can add them to any of these layers, but it doesn't make sense really at the machine level because machines don't play well with other machines. It doesn't make sense very much at the host level because IP addresses, that's where IP address is happening, and they're likely to change. So it's best to add the identity to processes themselves.
Mm-hmm.
And then just because I love semantics, when we say workload, we mean process. That's the same thing. Processes and workloads. We've been using those two words interchangeably this whole time. So then we talked about SPIFFE's designed to solve these problems and kind of a workflow for an app workload or process being able to get an identification from SPIFFE. So SPIFFE has a standard for formatting an ID called a SPIFFE ID that looks like a URL. But basically, there's this thing called an SVID, 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 which stands for SPIFFE Verifiable Identity. Oh no, document.
Yay.
So this SVID, as in my head, it's like you said a passport or a driver's license. It's basically a workload has the ID and it proves that the workload is whatever that workload claims to be. So the workload API is what gives SVIDs to workloads. So let me back up and talk more about the architecture of the SPIFFE stuff. Oh, so this is SPIRE stuff, not SPIFFE stuff. Interesting. Or did I write it wrong?
SPIRE stuff, but SPIRE follows SPIFFE standards, so by extension can be SPIFFE stuff as well.
Okay, great. That's why we do this recap part. So we have a SPIRE server. So this is typically a stateful set in a Kubernetes cluster. And this is the software that stores the SVIDs and distributes the SVIDs. And then we have SPIRE agents, which are typically a daemon set. And then, so there's a SPIRE agent on each machine, and that receives the SVIDs from the server. It exposes this workload API that we're going to talk more about. And then it does the work of actually verifying the workloads and giving them these SVIDs, their own little passports. And so each service agent has its own workload API. So now back to this. So the workload API is what we say here is what gives SVIDs to workloads, but it would also be correct to say SPIRE agents give SVIDs to workloads.
Yeah.
But when a workload wants an SVID, first they'll attest themselves and they'll gain it to the workload API. And then the workload API can verify this attestation by querying other stuff in the environment. So it might, if it's a Kubernetes environment, it might query the kubelet and say, hey, is this workload what it says to be? It might be querying the OS, the operating system. It might check the SHA hash, but it's doing, depending on what type of workload is asking for identity, it's doing stuff it seems very smart. It's doing stuff to verify
those
that
are
identity.
done by plugin. I didn't dive into details, but like for all of those attestations, there is a dedicated plugin. So you integrate, you define to use that plugin in the configuration of SPIRE agent, and also on the SPIRE server, I guess sometimes, and then via those plugins, that's also what makes it flexible. Though, if you have a system that is totally your invention and doesn't have a plugin, you can write your own plugin, and then it will do the attestations as well. Which
so this is something you configure when you set up.
You configure, and you can also as long as you follow the standards and provide a SPIFFE designed way to attest your stuff. For example, like if it's say I don't know, the first thing comes to my mind is VMware ESXi hosts. So if you want ESXi to be SPIFFE verifiable, then you need to write a plugin for ESXi SPIFFE attestation. And in that case, the Spire server, Spire agent, whatnot, can talk to ESXi host, which would be a great project, by the way. If somebody is around who does that, join to the community, do it, and like VMware can benefit it. Like just a slight advertisement. But yeah, but it's just a general, not just ESXi or anything that you do. If you provide that a plugin for it, then it will be SPIFFE verifiable.
Okay, and we have a question. What's XE?
ESXi.
ESXi.
Elastic Sky. I'll just Google it. What is extend? I would just ChatGPT it, I guess. ESXi. ESX. I'll just ask ChatGPT. That's faster. What is the extended form of? And I can typo in ChatGPT. That's the best part. I like it. ESXi, and it figures it out. So it's something Elastic Sky X integrated. So it is a bare metal hypervisor that is from VMware by Broadcom, meaning it can be installed directly on a physical hardware to manage virtual machines, essentially.
Cool. All right, so back in our story, our workload API is verifying that our workload is who they say they are by some sort of method that's been configured when SPIFFE was set up. And then once this process is complete and the workload is verified, then this workload API issues the SVID to the workload. And this workload API is also going to handle rotating SVIDs, revoking SVIDs, distributing, compartmentalizing SVIDs. So it's doing everything. Yeah. And also SVIDs are very short-lived, so therefore it's more secure than a longer lasting.
Yeah, and it's also configurable. Like by default, it's a day, but you can, if your security requirements are more strict, you can, let's say, rotate them in an hour instead of a day. But in that case, that rotation means, extra computation. Yeah, extra compute. So it's like a trade-off, depending on how much you can tolerate to keep your SVIDs around.
So then what this looks in practice, if two different workloads each have their own SVIDs, then they can usually, they establish a secure connection between each other. And that's how it works. Yeah. So to wrap it all up, is there anything else you want to say about how it works before I dig in on the benefits?
No, I maybe later say a couple of things that didn't came to my mind before. So one question would be, how do I convince my boss to use, SPIRE? And the other is like, what kind of advice would someone like me can give to those who wants to contribute to the community, or how to learn more about SPIRE and things like that?
Okay, great. Let me wrap up these benefits, and then we'll hand it to you to answer those two great questions, and then we'll dance.
Yeah. Okay.
So, benefits of SPIFFE. So neither your platform nor your workloads needs to deal with certificates or tokens anymore. So there is no spoon.
Yeah.
And then SPIFFE manages potentially complex cross-platform and cross-cloud identity layer. So that's pretty cool too. There's no more need for secrets management. It scales really well. And then these short-lived SVIDs are more secure than the longer-lived X509 certs, even though X509 is involved in this process.
Yeah.
And that said, so tell us how to convince your boss that you need to switch. How to convince her that you need to switch to SPIFFE. Yeah.
Me convincing my boss was a longer story, but I'll just create a genericized version of it. So you can put out the benefits, of course. Like, for example, it is a secure and automated way to manage identities. Zero trust security is a biggie nowadays. So when you say zero trust to anyone, and maybe at a pinch of AI, then you can even get an investment and found a company. So scalability, it's like it can scale infinitely. Interoperability with other systems, and also it has been adapted by major companies like Amazon, Microsoft, GitHub, Netflix, Square. Uber is a big SPIFFE user. Pinterest, Square, TransferWise, a bunch of others that I don't remember. So it is battle tested and it's proven. It's not the fact that, their boss doesn't know it doesn't mean that it's non-existent. Let's say it that way. So it has a wide community support. Like I said, it's a CNCF graduate project, and graduating from CNCF, it takes you have to pass a bunch of benchmarks to be there. So it is well supported, and including what happens if a core contributor leaves, what's the bust factor? Will the project continue? So all of them are sorted out. It is there and it is kicking. Other than that, like I said, there are future work items that we are working on. So in conclusion, advocating for the adoption of SPIFFE and SPIRE will involve, those highlighting those items, I guess, and also telling your story. Like I told my story with the help of you, Whitney. So if you are a good storyteller, I think you can convince your boss as well.
Wonderful. And what if I want to contribute to the SPIFFE community?
Yeah, for that, I think the first step could be understanding the basics, and that can go twofold, like understanding the basics of how a public key infrastructure works, like how all of these, certificate authorities, certificate chains, and in theory, how those works. And also reading the official documentation and understanding what SPIRE server does, what a workload API does, how do they interact, and things like that. The second thing I can recommend, and I cannot recommend it more, is to have hands-on experience. Like there are lots of tutorials on the SPIFFE website that you can follow. And there are lots of other videos and tutorials that other people in the community, myself included, have contributed to. You can watch and follow them as well. So imitate them, mimic them, because, best way of humans, back to neurology, humans learn by, imitation. So the best way to learn it to, copy somebody until you, attain your own style. And then it is staying up to date. We have a Slack channel. I don't remember how you get it, but you can get it on the website, which the link was broken, but I think somebody is working on it. Worst case, ping me wherever you are and I can invite you.
I found my way there. That's how I got Volkan to come on.
Yeah. When you find your way there, that link was working. Now it's giving some server something error, but I'm sure they'll fix it. Other than that, there are blogs and use cases on the website. Read them, learn about potential use cases. In deepening your security knowledge, it will always help, because everything revolves around identity and security. And I would say contribute, just update the code, update documentation, ask questions in the Slack channel, try helping others. We are a really welcoming community, and we want contributors from everywhere to help us, make things better. But yeah, that's it.
We have some,
I guess,
great comments. Taniwa said it's been a very spiffy stream, and Taniwa also said good S video.
All right. So, can I give a dad or mom joke award to?
And then Abhishek had some really kind stuff. Epic tra-la-la. Thank you. And Abhishek says, thanks, Volkan, for an enlightening session with valuable insights and information.
Tiny Korean hearts
like
this.
Whitney for good energy. Thank you. Looking forward to the next one, Abhishek. Woo, we did it. Okay, we're going to dance our goodbyes. Thank you, everyone, for hanging out and staying till the bitter end. This has been a blast. And we'll see you again next time. And thank you, Volkan, for sharing your
sure thing. I hope I was able to clarify some questions at least.
You totally were great. You're wonderful. Yeah, bring it. Yeah. Bye, everyone. Thank you.
Bye.